Forget GPT-4. Forget the days when Silicon Valley was the only place where frontier AI was born. We have officially entered the era of the trillion-parameter war. And for the first time in history, the most disruptive leads aren't coming from San Francisco or Seattle. They're coming from the high-rises of Beijing and the labs of Hangzhou. We're talking about models so massive and so efficient that they are fundamentally breaking the scaling laws we thought were set in stone. This isn't just about a chatbot that can write a poem. This is about a global shift in cognitive power. While the U.S. giants are focused on safety guardrails and multi-billion-dollar compute clusters, companies like Moonshot AI and Alibaba are proving that you don't need the most money, you just need the best math. We are witnessing a 1 trillion parameter collision between Kimi K2.5 and Qwen3-Max-Thinking, and the fallout is going to redefine who owns the future of intelligence. To understand the scale of this war, you have to look at the models themselves. First, let's talk about Moonshot AI's Kimi K2.5. This isn't just an upgrade, it is a native multimodal monster. It's built on a mixture of experts architecture with a staggering 1.04 trillion parameters. But here's the kicker. It only activates 32 billion parameters per request. It's a specialized brain that only uses the parts it needs, making it faster and cheaper than anything OpenAI has put out this year. Then you have Alibaba's Qwen3-Max-Thinking. Alibaba didn't just build a model, they built a reasoning engine. Qwen3 is trained on 36 trillion tokens. That is a library of human knowledge so vast it's hard to even comprehend. It's designed specifically for high-stakes cognitive tasks. We aren't talking about helping you write an email. We're talking about PhD-level physics, complex architectural engineering, and autonomous code generation that can refactor entire repositories in seconds. These models aren't just chatting. They are thinking. They use test time scaling, meaning they take extra time to ponder a question, self-reflect, and correct their own mistakes before they ever give you an answer. But the real game changer, the spec that makes every power user's jaw drop, is the context window. Kimi K2.5 is sporting a massive, nearly lossless context window that can handle millions of tokens. To put that in perspective for the gamers out there, imagine taking every single PS5 game manual, every lore book from the God of War series, every script from The Last of Us, and every frame of a 100-hour Ghost of Tsushima walkthrough. You upload all of it at once. You don't ask for a summary, you ask Kimi to find a specific, obscure, legendary item hidden in a frame of video from hour 42, and then you ask it to write a 50-page strategy guide based on the hidden lore it found in the manuals. It doesn't just remember the data, it understands the relationship between the video, the text, and the game mechanics. This ultra-long context effectively turns the AI into an infinite external hard drive for your brain. Whether you're a developer uploading 1 million lines of legacy code or a researcher processing 10,000 medical journals, the 2 million token window means the forgetting problem of AI is officially over. The technical architecture behind this is even more insane. Kimi K2.5 introduces what they call agent swarm technology. Most AIs are single agents, one brain doing one thing. Kimi can coordinate up to 100 specialized AI agents simultaneously. If you give it a complex task, like building a food delivery startup from scratch, Kimi doesn't just give you a business plan. It instantiates a food marketing agent, a logistics agent, a back-end dev agent, and a UI/UX agent. These agents then talk to each other, debate the best strategy, and execute parallel subtasks. It's not a chatbot anymore. It's a virtual corporation. Meanwhile, Qwen3 uses experience cumulative test time scaling. Instead of just running multiple paths in parallel, Qwen3 iterates within a single conversation, reusing its own intermediate reasoning traces as experience to get smarter with every turn. It's the difference between a student guessing the answer and a student showing 10 pages of work to ensure they are 100% correct. This leads to the most uncomfortable truth for the Silicon Valley elites, the efficiency revolution. We used to think that to win the AI war, you needed to spend $100 billion on power plants and H100 GPUs, but the 2026 data is shocking. While U.S. tech giants are burning $500 billion on infrastructure, a Chinese startup recently trained a competitive frontier model for just $6 million. How? Through pure automated reinforcement learning and better architectural math. They are weaponizing open weights. By releasing the weights for models like Kimi K2.5 under an MIT license, they're letting the global community improve the models for free. This is a strategic move to kill the closed-source moat. Why would a company pay OpenAI $30 per million tokens for GPT-5 when they can run a 1 trillion parameter Kimi model on their own local servers for a fraction of the cost with better privacy? So is OpenAI losing its edge in 2026? The numbers say the gap is closing, fast. In 2025, U.S. models held a near monopoly on high-end reasoning. By early 2026, Chinese models have jumped from 1% to 30% of global usage. They're winning on price, they're winning on context, and in the world of programming and design, they're starting to win on performance. OpenAI is still the king of general tasks and ecosystem integration, but for specialized, high-intensity work, the trillion-parameter war is currently being won in the East. The era of the king of AI is over. We're moving into a pluralistic world where you don't just use the best AI, you use the AI that fits your specific workflow. Whether it's the reasoning power of Qwen3 or the agentic swarm of Kimi, the frontier has moved. The wall of Silicon Valley has been breached, and the weapons of the next digital revolution are now open source, affordable, and more powerful than we ever imagined. The question isn't whether Apple or Google will catch up. The question is, how long can the U.S. giants justify their massive price tags when a $6 million model is doing the same job for pennies?